Hello, good morning to everyone. Myself, Dr. D. Sudhakar, working as Professor and Head at Department of Mechanical Engineering at Siddhartha Institute of Science and Technology, Puttur. Today we are going to discuss about this introduction to modern machining methods. This modern machining methods is also called as a non-traditional machining process or advanced machining process or special manufacturing process or unconventional machining process. These are all the synonyms for this modern machining methods. This modern machining methods is defined as a group of processes that removes excess material by various techniques involving mechanical, thermal, electrical or chemical energy or combination of these energies, but do not use a sharp cutting tools as it needs to be used for traditional manufacturing process. It means that in case of this traditional machining processes, as usually we required a sharp cutting tools to remove a material from the workpiece. But whereas in case of the modern machining methods, we do not need any sharp cutting tools, but with help of this mechanical energy or thermal energy or electrical energy or chemical energy or combination of these energies, we can use to remove the material from the workpiece. The extremely hot and brittle materials are difficult to machine by traditional machining processes such as turning, drilling, sharpening, and milling process. So by means of these modern machining methods, we can machine any material irrespective of their hardness and brittleness. The non-traditional machining processes are also called as advanced manufacturing process are employed where the traditional machining processes are not feasible, satisfactory or economical due to special reasons are outlined here. So wherever these traditional machining processes are not feasible or not satisfactory or unable to reach the economical conditions, then we can choose these non-traditional machining processes or modern machining methods to remove the material from the workpiece. The conditions are like wherever it's there, very hard materials are there. When the material is very hard, it is very difficult to machine by traditional machining processes. In that conditions, we can use these modern machining methods. And whenever the workpiece is too flexible or too slender, means when the workpiece is too flexible, it's very difficult to cut or machine by traditional machining methods. In that case, by means of these modern machining methods, we can cut any material irrespective of their flexibles and slenderness. When the shape of the part is too complex, suppose if you want to manufacture any component and if the component is very complex in shape, then those complex shapes is not easy to manufacture by means of the traditional machining methods. In that conditions, we can prepare or manufacture those components easily by these of modern machining methods. The several types of non-traditional machining process have been developed to meet the extra required machining conditions. When these processes are employed properly, they offer many advantages over non-traditional machining process. Means when compared to this modern traditional machining process, these modern machining methods or advanced machining process or non-traditional machining process are gives many more advantages. The common non-traditional machining processes are described in this section. The non-traditional machining processes are characterized as follows. The material removed may occur with chip formation or even no chip formation may take place. It means that in modern machining methods or whenever you employ these modern machining methods to remove the material from the workpiece, it creates or it produces the workpiece with or without chip formation also. For example, AJM. AJM means advanced in abrasive jet machining process. Here, the chips are microscopic in size. Whereas in case of the ECM, that is the electrochemical machining process, where the material removal occurs due to the electrochemical dissolution at atomic level. In case of this abrasive jet machining, the chips are formed, but the size of the chips are very small. But whereas in case of the electrochemical machining, we cannot see the formation of the chips also because the material is removed due to the electrochemical dissolution at a level of at the atomic level. In case of this non-traditional machining process or advanced machining process or modern machining process, they may not be a physical tool present. See, in case of these modern machining methods, there is no need of any physical tool required in order to remove the material from the workpiece. For example, in case of the laser beam machining or laser jet machining, the machining is carried out by means of a laser beam. Here, the physical tool is not present. However, in case of the electrochemical machining or ultrasonic machining, there the physical tool is very much required for machining process. And another point is in case of these modern machining methods or non-traditional machining methods, the tool needs to be harder than the workpiece material. For example, in case of the traditional machining process, whatever the tool we are going to use to remove the material from the workpiece, the tool hardness should be stronger or harder than the workpiece material. But in case of the non-traditional machining methods or modern machining methods, it is not required. We can use a less harder cutting tools in order to remove the material from the high hardness materials also. In case of the EDM means electric discharge machining process, where we are going to use a copper as a tool material to remove the material from the hardened steels also. Mostly the non-traditional machining processes do not necessarily use the mechanical energy to provide the material removal. See, in most of the machining process, what we are going to use in case of these modern machining methods, here we do not need or we do not necessarily require the mechanical energy to remove the material from the workpiece. Apart from that one, they use the different energy domains to provide the machining. For example, in case of the ultrasonic machining, abrasive jet machining, water jet machining, mechanical energy is used to remove the material from the workpiece. What is the need for the development of these modern machining methods or non-conventional machining process or unconventional machining process or special manufacturing process? The strength of the steel alloys increased fivefold due to the continuous research and development efforts. See, from the Second World War, the scientists are developed or concentrated more on different materials which are required for the preparation of these turbine materials, turbines in case of the aviation industry. So, in that condition, whatever the material they developed during these aerospace requirements, those materials are not possible to cut by the conventional machining process because of the elevated temperatures and high strength. And because and these high strength at elevated temperatures with lightweight materials are not possible to cut by conventional machining process, and there is a need to develop the advanced machining process in order to machine such as titanium alloys, pneumonic alloys, and other high strength temperature resistance alloys. The ultimate tensile strength has been improved by as much as 20 times during the Second World War and whatever the material is developed during this time. The development of cutting tools which has hardness of 80 to 85 HRC, which cannot be machined economically by conventional machining methods, lead to the development of non-traditional machining methods. And because of this high strength and high temperature resistance and high hardness of the materials development, and there is a need to develop these modern machining methods or non-conventional machining processes. Another point is technically advanced industries like aerospace, nuclear, power, water fabrication, wafer fabrication, automobiles has ever increasing uses the high strength temperature resistance alloys. Because of this development of these high temperature, high strength and temperature resistance alloys, in case of all these industries, there is a need to develop the advanced machining process to machine all these materials like titanium, pneumonics, ceramics, and semiconductors. And it is no longer possible to use the conventional machining processes to machine these alloys. For that, there is a need for the development of this non-conventional machining process. The production and processing parts of complicated shapes in high strength temperature resistance allies, there is a need for the development of this non-traditional or non-conventional machining process. Innovative geometric design of products and components made of new exotic materials with a desired tolerance surface finish cannot be produced economically by conventional machining process. So wherever there is a requirement of exotic designs and high tolerance and high surface finish, and these requirements are not possible by conventional machining process, and because of this one there is a need to develop these modern machining methods. Another point is the following examples are provided where these non-traditional machining methods or modern machining methods or processes are preferred over this conventional machining process. The first point is intricate shape blind holes. Wherever, if you want to manufacture, if you want to create the intricate shaped blind hole, then it is not possible to cut by means of this conventional machining process. That's why we should go for to use these modern machining methods. And difficult to machine materials. For example, inconel, titanium alloys, carbides, ceramics, composites, high strength temperature resistance alloys or stellites. These are the high strength and high hardness materials. And it is very difficult to cut by conventional machining process. But in case of these modern machining methods, we can cut easily. So for that one, there is a need for the development of non-conventional machining process. And low stress grinding. The electrochemical grinding is preferred as a compared to the conventional grinding process. In case of the conventional grinding process, there is a direct contact between the tool and workpiece. Because of there is a direct contact between the tool and workpiece, a very high temperature is developed because of the friction. Because of this temperature, the tool or the workpiece properties may change. But whereas in case of this electrochemical grinding and that much temperature or friction is not developed, because of that one, without any changing in the properties of this workpiece material or tool materials, we can cut any shape without any problems. And deep hole with small hole diameters. See, whenever if you want to create a hole with very small diameter and with a high length, then automatically it's very difficult in conventional machining process because the drill bit may break if the length is more when comparison to the diameter of the drill bit. But those type of the deep holes with help of small diameter can easily produce by means of these modern machining methods. The machining of composites are also very difficult by means of this conventional machining process. But whereas with help of these modern machining methods, we can easily cut any complex shapes, any shapes without any problems. Now coming to the differences between the conventional and non-conventional machining methods or modern machining methods. Conventional machining methods and modern machining methods. Coming to the point one, the cutting tool and workpiece. In case of this conventional machining process, the cutting tool and workpiece are always in physical contact with relative motion with each other, which results in friction and tool wear. See, in case of the conventional machining process, suppose take any lathe machine or drilling machine, slotting machine, any conventional machine tools, there is a direct contact between the tool and workpiece. And because of this direct contact between the tool and workpiece, there is a friction. Because of the friction, very high temperature is developed. Because of this high temperature, the tool or workpiece properties may change. But whereas in case of non-conventional machining process or advanced machining process, there is no direct contact between the tool and workpiece. In some non-traditional machining process, tool wear exists. Example, in case of the electrochemical machining or ultrasonic machining, there some tool wear is there. But in case of other non-traditional machining process or modern machining methods, the tool wear is nowhere a tool wear exists. Coming to the point number two, material removal rate is limited by mechanical properties of the work materials. In case of the conventional machining processes, the material removal rate means the MRR is completely depend upon the workpiece material. If the workpiece is too hard, then very the less MRR will be takes place. If the material is somewhat soft, then we can remove more amount of material. But whereas in case of the non-traditional machining methods or modern machining methods, the difficulty to cut materials or the hard materials can be cut like material, titanium, ceramics, pneumonics or composites or semiconductor materials without any irrespective of their hardness. Then the relative motion between the tool and workpiece is a rotary or reciprocating. Thus, the shape of the work is limited to a circular or flat shapes. In case of the conventional machining process, most of the shapes we can produce like circular shape or flat shapes. Even though we use the CNC systems, the production of 3D surfaces is still difficult task. But whereas in case of the modern machining methods or non-traditional machining methods, we can produce any shapes without any problems. Even complex 3D shapes or cavities can be produced without any problems. Then machining of small cavities, slits, blind holes or through holes are difficult in case of the conventional machining process. But the machining of small cavities, slits, production of non-circular, micro-sized, large aspect ratio, shell entry, shell entry angles can easily create by means of these non-traditional machining methods or modern machining methods without any problems. In case of the conventional machining process, use relatively simple and inexpensive machinery and readily available cutting tools. So whatever the machines what we are going to use in case of machine tools, in case of this conventional machining process, those are inexpensive machinery and readily available cutting tools. But whereas in case of the non-conventional machining process or modern machining methods requires expensive tools and equipments as well as skilled labor, which increase the production cost significantly. But whereas in case of the conventional machining process, as there is no inexpensive machine, as there is a inexpensive machinery and readily available cutting tools and unskilled labor also can run these machines, the production cost is less. But in case of the non-conventional machining process, the production cost is high because of these expensive tools, machinery, and labor is also required. In conventional machining process, the capital cost and maintenance cost is less. But whereas in case of the non-conventional machining process or modern machining methods, the capital cost and maintenance cost is high. Then coming to this traditional conventional machining process, the traditional processes are as are well established and physics of the process is well understood. See, as we are using this conventional machining process or traditional machining methods lost from the second industrial revolutions, and we know very well how the material is removed and what is the mechanics involved in the removal of material from the in case of the conventional machining process. But whereas in case of the non-conventional machining process or modern machining methods, the physics of the metal removal or the mechanics of the metal removal is still under research, and completely we didn't understood how the material removal is takes place and how the heat will be transferred to the workpiece and to the tool material, and still under research only. Now coming to the next point, the conventional processor mostly uses mechanical energy. See, in case of take any lathe machine or drilling machine, boring machine, reaming machine, or any conventional machining process, in all these cases, we are going to use the mechanical energy to remove the material from the workpiece. But whereas in case of a non-traditional machining process or modern machining methods, we use the different form of energy like laser energy, electron beam energy, or in other chemical energy, electrochemical energy in different machining methods to remove the material from the workpiece. Now coming to the conventional machining process, the surface finish and tolerances are limited by machining inaccuracies. See, in case of this conventional machining process, it is very difficult to produce a high surface finish and high tolerances because of the workpiece may very hard material or tool material because of this limited characteristics of this tool and workpiece characteristics. But whereas in case of the non-conventional machining process, high surface finish up to 0.1 micron is possible, and at the same time tolerances like 25 microns are also possible. In case of the conventional machining process, metal removal rate is high, but whereas in case of the non-conventional machining process, the metal removal rate is low. This is one of the drawbacks of this non-traditional machining process or modern machining methods.